Good evening, everyone. Today, my AAT Tech Talk topic is earthquake resistance, accessing building strategies on thawing permafrost ground. This AAT presentation is given by N. Rishabh of Civil Engineering Section A. My rule number is 24955A0115. So let's begin. Introduction. This presentation explores the challenges and solution of building earthquake resistant structure on thawing permafrost. It aims to provide insights into the characteristics of permafrost, the implications of thawing, and the techniques used in construction and engineering to ensure safety and sustainability in vulnerable areas. First, permafrost overview. Let's look into it. Characteristics of permafrost. Permafrost is a layer completely frozen soil. It varies in thickness, composition, and temperature, influencing ecological and building conditions. Understanding its properties is crucial for construction planning. If we do proceed without understanding about these characteristics, we may have problem in construction planning. Construction, the structure may fail due to the changes in these properties. Effect of climatic change. The climate change is causing permafrost to thaw at increasing rates. This results in change to soil composition and sustainability, leading to challenges for existing and new infrastructure. Types of permafrost. There are two primary types of permafrost: continuous and discontinuous. Continuous permafrost is found in polar region, while discontinuous permafrost occurs in more temperature areas. Before both types have unique implications in construction. Impact of thawing. Let's now look into the impact of thawing. Soil sustainability issues. Due to thawing, we will have soil sustainability issues. Thawing permafrost can lead to soil instability, causing ground subsidence and shifting. These conditions necessitate careful engineering assessment for building foundations. Due to this, the landslides may occur due to the soil instability. So we need to be more careful about this. Hydrological changes. Thawing alters hydrological patterns, result in increased water runoff and changes in drainage. Understanding these changes is essential for preventing floods and managing water resources. Effects on infrastructures. As paramount thaw, existing infrastructure is at risk. Due to this, we will have more number of moisture content which will penetrate inside the building, inside the cement outer layer, and which will initially weakens the body of the building, which will eventually damage the structure. So these thawings can lead to structural damage, requiring retrofitting or rebuilding efforts to ensure safety and longevity of buildings. Now we'll look upon to the building techniques. Design considerations. While designing buildings in permafrost region, engineer must consider thermal inflation, moisture control, and structural flexibility. These aspects ensures that the buildings adapt to temperature changes and minimal damage during thaw periods. So we need to be careful while designing, and we need to take design while considering the permafrost conditions in permafrost region. By these, we can control the damage, and we can reduce the damage caused to structure due to this permafrost toss. Foundation types for permafrost. Various foundation types are used, including pile foundations that reach stable soil below thaw layers. These methods distributes weight effectively and reduce risk of settlement or shifting. So using pile foundations, which will pile foundation which will reach deeply into soil, will distribute the weight effectively and reduces the risk of thawing and sliding of landsliding. Material selections. The choice of materials is crucial. They must resist moisture content, moisture, and temperature influences. Insulated walls, flexible joints, and appropriate roofing materials enhance durability and stability in dynamic conditions. So, the materials which are selected for the structural use should resist the moisture and temperature fluctuations. So then we will have a good and rigid structure. Engineering solutions. Now let's look upon to engineering solutions. Monitoring and assessment. Regular monitoring of structural integrity and soil condition is essential. Technologies such as sensor and drone surveys provides real-time data, allowing for early interventions if issue arise. Retrofitting existing buildings. Older structure may often be retrofitted to improve stability. Techniques includes reinforcing foundation and improved drainage to mitigate the effects of thawing forecast. So using retrofitting, we can reduce the permafrost up to a limit. Innovation construction methods. New construction methods such as elevated buildings and use of high resistive materials such are being developed. These innovations aim to minimize the thermal impact and adapt to the changing landscape of thawing permafrost. So now the new inventions are being done, which can be resist the these we can which can resist heat resistant and which can resist the thawing permafrost. Using these materials we can build, or we have another options by building the building by constructing a building at an elevation. Case studies. Now let's look upon the case studies. Successful structures on thawing permafrost. Example of successful building includes those using insulated piles and innovative ice-based insulation system. These structures demonstrate effective adaptation to environmental challenges. Failure and lesson learned. Analysis of failure structures reveals critical lessons about soil information in monitoring, foundation design, and the importance of local climate understanding. These insights guides future projects. Future projects and planning. Future construction in permafrost areas will increasing incorporate sustainability consideration and advanced climate resilience strategies, focusing on adapting to ongoing environmental changes. Now, finally, in conclusion, in summary, addressing the challenges of building on thawing permafrost requires careful planning and innovative techniques and ongoing assessment. So we should monitor the soil time to time in permafrost region, and we need to be careful in planning innovative and should innovate techniques and ongoing assessment. Successful adaptation is key to ensure safety and longevity. By we should adapt to the changes which are happening in the soil in this paraforce region, and by learning from previous failures we need to mitigate to the new technologies, and to we need to deduces, and we need to take careful planning and innovative techniques for this paraforce region. Thank you.